Hi folks, this is activity number 2 of the week 7 of the CAD course in winter 2026. Uh, the problem is for you to use the generative shape design to create a surface like that and create a design table based on something that is shown on the right hand side. I want to point out to you that in the past, some of the other years, I have done the design table approach based on the scenario 1. And scenario 1 is the one that, or scenario 2 actually, is the one that I give you the table, you create the part. This is the other way around. This year is the other way around. I give you the part. I'll tell you what the part is, and you create the design table for it. At the end of the day, when it comes to doing this thing on the final exam, that's entirely up to you how you want to do it. I need a spreadsheet, Excel spreadsheet, and I need the part which is uh, associated with that spreadsheet uh, for having created design table. So my approach is scenario 1. Please look at the course PowerPoint, and that means that you start making this part, and once you make that part, then you create a design table from that part. Okay. All right. So let's go ahead and do that. Let me go here. Where is it? Yeah, Catia. Let me start with, because we're dealing with surfaces, immediately you go and do a part. Generative shape design, that's really what I meant. And let's go and make a nominal part. On that plane, I will sketch a circle. To make my job easier, I'll center it like that, okay? And I give this thing a dimension, and let's go ahead and see here. First of all, my units are in millimeters, so I'm gonna switch my units. Forgot to do that, tools, options. From inches, I'm gonna go to millimeters, okay? Then I noticed that the nominal part that I'm going to make has a radius of or big of 50. So I'm going to give this dimension 50 millimeters. Okay, exit. Now I want to put a surface through that. So in the generative shape design, I go and do a fill, F-I-L-L. So like this, as long as it's nice and closed, it'll put a surface through it. Okay, now there are different ways of doing these problems. It's entirely up to you, but here's the way I'm going to approach it. I'm going to make a small circle on the surface, okay? And then make a circular pattern of that. And then join the circular pattern and that first circle that I made, first circle meaning first small circle, and then use a split. Okay, so let's go ahead and do that. You do it any way you want, as long as it does what it's supposed to. So on that plane, I will sketch. First of all, where the center of that thing is, what I'm going to do is I'm going to, actually, let me do the following. It's okay. So I'll make that little circle here, anywhere you want. It really doesn't matter. There we are. And dimension this. There we are. There's a radius. Now, what do I want the nominal radius to be? That's all 5 millimeters. Okay, so let's see what it is right now. It's almost 5.5. That's okay. Excuse me. And we want the distance from the center of that to the center of the big circle to be 15. That's what I mean by R mid. Okay, so let me go ahead and put a dimension from here to here, and this is going to be 15. Good. Yep. Yes. Okay. Now I'm going to exit. So Notice that I have created the sketch, okay? And what I'm going to do is I'm going to make a circular pattern of that sketch, complete crown. I'll make it 5 or 4, doesn't matter. And for the reference surface, for the reference element, I can use the Z-axis or I select that surface. It doesn't matter. I'll do the Z-axis. Notice that it did it for me. And that's good. Okay. You might say, okay, now that we did this, why can I not go ahead and use the split? The problem is that if you use the split and you select that first circle that you made, okay, cutting, let me do that again, let's try it again. Split, select the surface, cutting element is this. The problem is that if you only do this, it won't do the other one. Cancel that. So in order to make sure that they're all cut at the same time, this is how I'm going to suggest that you do it the way you want. Here is join, join, that initial circle and the circular pattern. And then we say okay. That's okay, but let's see for a second. Notice that it says this is a non-connex result. That's because these things are all separate from each other. Say no, and uncheck this connexity. See that? See there is this thing. It gave me a message about connexity. It was complaining about this. So check connexity. Say don't do it. Uncheck. And now we say preview or okay, and it'll do all of them. Good. Now we can do a split. Now we do the split. For the split, we the cutting element is that join. That join. Okay. I'm sorry. Cancel. Try it again. Try it again. No problem. Where was that cut split? Read this thing carefully. Element to cut is that surface. Cutting element is that join. That join. See that? You can also select this one. It doesn't matter. Join or this. It makes no difference. Okay. You say okay, and say okay. All right. So this was the first step. This was only the first step of making the nominal part. Now we have to create the design table. And remember, the approach that I'm taking is scenario 1, which means that I'm going to do the renaming. So how do we do that? We go to f of x, and we select our part. So it shows us the dimensions that we want. For example, this is our mid. So this is going to be our mid. Okay? This is going to be our hole. Our hole. And this is going to be our big. Big. Okay. Now, there is also the number of things that are used in this circular pattern. So how do we do that? Just scroll through it, find where you find that 5 right here. See that? Angular number right there. Right there. You see this? Angular number. I'm going to change this thing, the name of this thing, I'm going to change it to N. Okay? Apply. Now, if you want to see your rename parameter, these are the things that I renamed. Okay? R big, R whole, R mid, and N. And then we say OK. The final step is to go to the design table here. Design table. Remember, there are 2 radio buttons here. We don't want the first one. I'm not giving you a pre-existing file. I'm going to create a design table. Select this and then say OK. It says, all right, what are the stuff that you want to send to the design table? So the easiest way is to say, show me the rename parameter. I want the N to go there. If you want this particular order, because you can always change this ordering, but R big, R whole, and R mid, R big, R whole. So R big, or whole or mid, and then we say okay. It says, where do you want to put it? Well, I want to put it in this folder, February 17, activity number 2. There we are. And then we say okay. Assuming that there are no other issues, we'll wait. This thing pops up, and notice that it did put those things in it. N is 5, R big is 50 because I made it 50. R whole, I kept it at 5.58, whatever it was. And I made it 15 millimeter. Now, if you say edit the table, it opens up that Excel spreadsheet and says add whatever you want to it. So first of all, let me do a cleanup here. I want this thing to be 5. Okay, what else do we want there? We wanted 800, 390, 800, 390, 8 holes, 100, hole size is 3, distance from the center 90. What else do we want? We want 425, 10, 425, 10, 425, 10. Assuming that these numbers do not go, you can't just put random numbers here because it may make this sketches self-intersecting and things like that. Assuming that these are well thought of, and let me see that file, save as. Let me go to that folder. Yeah, that should be okay. Excel, that's okay, save. Okay, good. And then we're gonna close this. Yeah. Now, if you go to the next one and say apply, notice that you get eight holes. These are the radius of the hole, the distance from the hole, etc. The center. This one is going to be the one with the 3 holes, 4 holes actually. And then you can add stuff to it. You can modify it by edit table. You can do things. Now, a couple of things. First of all, yes, and then we say okay. Remember, when you submit your work on the exam, if this happened to be the problem, you have to give me 2 things. You have to give me the part and the design table, both of them. When you upload your files for marking, you not only have to give me the part, you also have to give me the Excel spreadsheet, okay? And one other thing, later on, we're going to be doing design table for assemblies. When you do that, you have to give me the product file, all the parts that go into the assembly, and the design table. If you don't give us, in the case of a single part, for example, if you don't give us the Excel spreadsheet, no good. We can't open your file. I can't mark your problem. All right, folks. So good luck.